Hello out there, guys. Welcome back once again. So I hope you're ready today. Encourage you again, doing your mathematics, have pen and paper. So I'm welcoming you today. My name is Rakubu. I hope you're ready. So we're going to focus on measure of dispersion and what it means. Okay. So let's see what I have today. And before we actually even look at measure of dispersion, I'd like to start with a question. And what do you think about the question? Let's see what is the question. How can one choose the best company for investment with low risk but high return? Okay? So you have money. You want to invest money, can be stock market, but you want low risk but high return. What do you look at? What is high return? I mean, that can be an average return. I mean, an investment company can promise you they'll give you an average, they'll give you 5% back, 5% interest rate, maybe per annum, or 6%. What if company A and company B, they say both, they'll give you 6%? What do you choose? Do you take company A or company B? So company A gives you 6%, and company B still gives you 60%. Are you going to take the two? They give same return, but what about the risk for each of the organization, of the company? Do you know what is the risk? How do you choose that? Usually, one will look at that, and we'll look at this in this concept. What is the deviation from this return? What is the average, which is something new, which is proper and interesting? What is the average deviation from the 6%? What if the average deviation from this was 10%, and this was 4%? What will you choose? Deviation, the average deviation, because the two companies, they give you 6%. What if the other company movement? You know, have you seen those stocks market graph? It just moves randomly, so volatile in finance, that's what they call it. And the other company, the movement, no, it doesn't move a lot. Which one do you choose? Usually that movement shows high risk of volatility. If not moving too much, probably a low risk. So same return, you can have a different risk. One can be high risk, okay? So usually if they offer you the same return, you have to look at the risk. And that usually you call it volatility, and we'll look at this measure of dispersion, which is called the deviation from the average, which is interesting. The deviation from the average. Nice. Okay. So what we're going to look at now is, we know what is 5-number summary, the box and whisker plot, the maximum value and the minimum value, which is actually the part of 5-number summary. Range, which is the dispersion, one of the dispersion, which is range, which is the maximum minus minimum. Interquartile range, which is the upper quartile minus the lower quartile, which is Q3 minus Q1. And the semi-interquartile range, which is half interquartile range. We're going to look at outliers. Interesting. Outliers, those are your extreme. Can be your extremes, doesn't fit within the data, something of that nature. So what you want to look is, how can we really quantify, if we have data, which is an outlier, okay? Can we look at it and point the outlier? Maybe, but can we come up with something that we can reason and arrive to a conclusion and say, yes, that is an outlier. Okay. We'll look at standard deviation. The standard deviation is another measure of dispersion. But the standard deviation is the deviation from the average, from the mean, the actual mean. So it's actually a more powerful measure of dispersion. Okay, and it measures the movement in finance, the volatility. What are you talking about? Beautiful. So let's look at some of the keywords. Raw data, grouped data. So we know that raw data given as 1, 2, 3, 4, 5 all the way randomly. That's raw data. And group data is when we group data with intervals and frequency on the frequency table. Okay, that's a group data. That's the difference between the two. And what about class interval? Class interval is on our frequency table. We might group data how many people, let's say, between the age of 10 to 20 with COVID positive, 10 to 20, that's an interval. Okay, you can create those kind of class interval, call it the class interval, actually. So what about extreme values? Extreme values are our highs and lows value given set of data. It can be extremely low or extremely high. Skewed, when you talk about skew or skewness, we're talking about your data distribution. It could be symmetric, skewed to the left, or skewed to the right. And modal class interval. Okay, now, when we have raw data implies 1, 2, 3, 4, we can see the actual data. We can tell, oh, 5 is a mode. But when we have group data, we can only tell the modal class interval. So the modal class interval is the interval with the highest frequency, the highest number in that interval, which is the highest frequency, or the highest tally, as we count the numbers that belongs in that class interval. Remember the class interval, I could group all girls between the age of 9 to 20 who are left-handed. Something like that. That will be an interval. Okay. So we're back here. So what are we going to look at now? We're going to look at the range. Interquartile range and semi-interquartile range. Those are the measure of dispersion. Range, interquartile range, and semi-interquartile range. So let's start with range. If the scores are spread out, then the range will be higher and the scores less consistent. If the scores are close together, then the range will be lower and the scores are more consistent. So range is maximum minus minimum. Read together. So range is the maximum minus the lowest or minimum. Okay. But the highest value minus the lowest value, if there's a huge gap between the two numbers, that tells us inconsistency with that kind of data. Okay. But the highest number minus the lowest number, if the deviation, the gap is smaller, there's some consistency with that data. Are we all together? For an example, okay, if I go to your class and I find that Johnny is getting 100% for test and Thomas is getting 10%. If I minus the 2, I'm getting 90. The deviation is 90. There's a 90% gap between the two of them. What it says that inconsistency in terms of the marks the distribution of the mark. Then I go to another class. I find student A, the highest mark is 70%, and the lowest mark is 65. Highest, 70, lowest, 65 minus. The gap is 5%. What can we conclude? Consistency in the data. But, range is not a good measure of spread because it can be affected by the extreme value. What if, yes, one student had a bad day, a difficult day, and yes, performed poorly in the test, and one student performed good? It doesn't look at the holistic, everyone in the class, hence can be misleading. So, the range is not a good measure of spread because one extreme, when we talk about extreme, is very high or very low value can have a bigger effect. So, we looked at range. Let's look at the 5-number summary. The 5-number summary must be know this by now, or the minimum value. Lower quartile, which is Q1. Median, which is Q2. Upper quartile, which is Q3. And maximum value. Those are the 5-number summary. What about the box and whisker plot? The box and whisker plot, you should know this by now, is another way of summarizing data using the 5-number summary, which is the lowest value, the highest value, median, which is the middle number, lower quartile, which is Q1, the upper quartile, which is what? Q3, which is the 5 whisker plot. So the box and whisker plot is also called a box plot. You can go with the box plot or the whisker plot. Graphic representation of 5-number summary. It's just how we represent the 5-number summary using the box plot. So which is the minimum, we spoke about that, lower quartile, median, upper quartile, and the maximum value. So this is our whisker plot. This is how it looks like. We have our minimum value there, our Q1 there, which is the lower quartile, Q2, Q3, and the maximum value. And which is, yes, there we have it. So now the box, the width is the interquartile range, the width of the box, which is that part. Can you see that? Q3 minus Q1 is the interquartile range. Okay. So the nice thing about the interquartile range is that it kind of, the extreme values do not affect the interquartile range because the interquartile range is from there to there. So it does not use the minimum and the maximum value. Because if I find the range using maximum and minimum, what if the maximum and minimum are extreme values? But with interquartile range, usually from there to there, you might not find the extreme value. So that's the interquartile range. The interquartile range is a measure of spread. Which is there, our interquartile range. The semi-interquartile range is just half of the interquartile range. Okay? So the range, not a good measure of spreads because it can be affected by what? The extreme, high, low numbers, or very high numbers. Are we together? But the interquartile range, very good because of what? Extreme values don't affect the number by it. But the semi-interquartile range is good for actually symmetric data. What are we talking about? The semi-interquartile range, which is there. The semi-interquartile range. Are we all together? Okay, so what are we going to do now? Let's look at that. Okay, so we said range, not good measure of spread because the extreme can affect the range. The interquartile range, better than the range because not affected by the extreme value. The semi, another good measure of spread, not affected by extreme, but good for skewed data. Okay, guys, we're going to take a short break. And when you come back here, we'll be carrying on with the measure of dispersion. See you shortly. Hello guys, welcome back once again. So let's go back to work. Let's see what we have. So box and whisker plot. So they're very good comparing distribution in different two data sets. If you have two data sets, you'll able to, to check symmetrical or normal distribution, positively skewed distribution, or negatively skewed distribution. What is the relationship between the mean and the median for this distribution? So we can use mean, which is the average, and the median, which is the middle number, to check with whether what data is, how it's distributed, to the left, right, or symmetric. Okay, let's see. So symmetric data, this is kind of symmetric. This box is the same as that side. Drawn to scale. What is the relationship between the mean and the median? Let's see that. That is symmetric there. So if the mean minus the median is close to zero, this is approximate, close to zero, we say the distribution is symmetrical. So median minus mean, if the answer is close to zero, that's symmetrical. Okay, by knowing the mean and the median. But also positively skewed data. So this is positively skewed. If you look at the box plot, it's more this side. Can you see? What is the relationship between the mean and the median? Similarly, what are we going to do? We're going to say the mean minus the median. If our answer is negative, smaller than zero, then this is skewed to the left. It's negatively skewed. Okay? If mean minus median, negatively skewed. And if mean, let's say mean minus median, it's positive. Therefore, this will be positively skewed. Are we together? Let's look at that. Mean minus median, zero, close to zero, symmetrical. Mean minus median, bigger than zero, positively skewed. Mean minus median, negative, negatively skewed. Good. Makes sense? Super. Consider the following sets of marks out of 10 for 3 classes. So this is the first class, class A. This is class B. This is class C. So in class A, there's someone who got 1 out of 10, 1, someone got 2, someone got 2, and we have 3 10 out of 10s. And this is class B. So what do we want to do for each class above? We want to create the 5-number summary and hence the box plot for each. Let's look at class A. If I look at class A, rearranged from the smallest to the highest. So we can see that the minimum value is 1, 5-number summary. The lower quartile is between 2 and 3. Are we together? Because the lower quarter is the quarter of the data. So it's 2 plus 3 divided by 2, we get 2.5. Median, which is the middle one, is 4. And lower quartile is between 8 and 9. 8 plus 9 divided by 2, you get 8.5. Then the maximum value is 10. Then we draw a whisker plot. There's a whisker plot with the minimum value, our Q1 there, Q2 there, Q3 there, and max. This is min. By looking at the whisker plot, what can you say about the distribution of the data? By looking at that, I can say this is skewed to the right. Can you see that that is skewed to the right? By just looking at the distribution of the whisker, by looking at the plot. But we can calculate the mean and check that. We'll discuss that later. Let's look at class B. So class B, the minimum value is 1. The lower quartile Q1 is between 4 and 4, which is between 4 and 4. Let's see that. So it can be 4.5. So 4 plus 4 divided by 2 should be 4, not 4.5. Okay, that's correct. Yes, should be 4. 4 plus 4 divided by 2 should be 4. Then the median, which is 8, is the middle number, arranging your data from the smallest to the highest. Then our upper quartile is between 9 and 9 there. So it's 9 plus 9 divided by 2, we get 9. Then the maximum value, which is 10. Let's look at our whisker plot. There's our whisker plot. Our minimum value is 1. Our lower quartile is 4, not 4.5, which is 4 there, which is Q1, that is Q2, that is Q3. And the maximum value, which is 10. What do you think about the skewness? I can see this is skewed to the left, this side. Okay? Let's look at class C. Minimum value, 1. Lower quartile 3, because 3 plus 3 divided by 2. Median 5, which is Q2. Upper quartile 7 plus 7 divided by 2. Maximum value, the highest value, which is 10. Then our whisker plot. What do you think about the distribution of this? If I look at that whisker plot, I can see that this is symmetric. Let's see now. Let's say we have the median. So class A, the median we know it's 4. The median for B, it's 8. The median for C is 5. The mean, we've calculated the mean for all of them. You can check. So those are the mean. Let's see. Class A. Mean minus median. Mean minus median. This is 1.4. 1.4, it's bigger than 0. The data for this class is positively skewed. Are we together? Class A is positively skewed. What about class B? Class B, mean, which is the average, 6 point, okay? 5 minus 8, we get minus 1.5, which is smaller than 0. What does this tell us? The data for this class is negatively skewed. And what about class C? Class C, mean minus median, which is the mean for class C, average is 5.4, the median was 5. If we minus them, we get 0.4, and 0.4 is close to 0. Then we can conclude that our data is symmetrical. Okay, hope it makes sense, guys. So now, what are you going to do? We're going to look at outliers. What are outliers? An item of data that is unusually small or unusually large is classed as anomaly or outlier. An outlier could occur as a result of error, e.g. measuring or recording of. The outlier might, however, be true value that is just happens to be very different from the rest. You've seen that. There might be a student who is just different from the rest. So it could be an error, but it could be different from the rest, which is okay, but it's an outlier. But how do we find this outlier from the data? So a simple rule that is often used is to identify outlier in this values R. So we're going to find a smaller value using this. We're going to say an outlier will be smaller than this. Q1 minus 1.5 times the interquartile range. Remember that the interquartile range is Q3 minus Q1. Or a value greater than Q3 plus 1.5 times the interquartile range. Those can be used to identify an outlier. Are we together? So let's see how. Outliers can be marked on a box plot or whisker plot using something like this. Could be a dot or an asterisk like that on our whisker plot. Say, oh, 100 is an outlier, okay, on our whisker plot. So let's look at the data. An annual salary in thousands of rands of 10 employees of a small companies are 12, okay, so it's 12,000, 14,000, 17,000, and so on. From the data, let's find the median. Let's find our quartiles, Q1, Q2, Q3. But before we do that, look at that. Can you tell which one is an outlier? By just guessing. Can you tell that which is an outlier? So the median salary is halfway between the 5th and the 6th. So that's the median because we arrange the data from the smallest to the highest. So the middle is there. So how we define the median? So it's 20 plus 21 divided by 2, which is 20.5. Are we together? That's the median. Then we can find the lower quartile. The lower quartile, which is the median from there to there. The middle, which is 17. Then what about the upper quartile? The upper quartile is the median of the largest 5 values. Can you see that? The median from there to there is 23. Are we together? Which is 23. The interquartile range, which is Q3 minus Q1, give us 6. And now let's see what we can do with this. So an outlier could be a value less than this. Q1 minus 1.5 times interquartile range. Our Q1, lower quartile, is 17. Minus 1.5, the interquartile range is 6. If we put this in our calculator, we get 8. What does that mean? A value less than 8 is an outlier, or a value more than this value. What is that value? Q3 plus 1.5 times the interquartile range. What is Q3? The upper quartile was 23 plus 1.5 times the interquartile range, which is 32. So a value larger than 32 or a value less than 8 from the given data is an outlier. From our data, do we have a value less than 8 or a value larger than what? 32. Do we have one? Let's see. So the value is 58 because 58 is larger than 32, which is an outlier. This is how we represent an outlier using our whisker plot. Does that make sense, guys? The 58 is our outlier. So what we're using to find outlier is just Q1 minus 1.5 times the interquartile range. If any value less than that, it's an outlier. A value larger than this, Q3 plus 1.5 times the interquartile range, that will be an outlier. So you just have to find quartiles, actually, to determine an outlier from your data set. Okay. So what are we going to do now, guys? We're going to take a short break. Then after the short break, we'll come back. We came to look at a powerful measure of dispersion. Fantastic. Good. Hello guys, welcome back again. What I said now, we're going to look at such a powerful measure of dispersion. Okay, we're going to look at something called the standard deviation. It's actually, think of standard deviation, you have raw data. You calculate the average. What you want is the average deviation of each and every individual data from there. Think about this. That's the powerful. Okay. So let's look at the standard deviation. So the measure of dispersion, spread of data. So we know the range, which is the maximum minus the minimum, the interquartile range, the semi-interquartile range, which is new, is the standard deviation. The range, not a good measure of spread, of dispersion, of spread. Because why? What do you think? We spoke about this because the extreme value can affect the range and not tell the story. Because you're only using the lowest and the highest value. It doesn't tell us anything about the middle. But the interquartile range is actually better than the range because the extreme values don't affect the interquartile range. And the semi-interquartile range, also the extreme values don't affect the interquartile range, but the interquartile range is good for actually skewed data, meaning skewed to the left and skewed to the right. Very good for that. Now, let's look at what is the standard deviation we're talking about. Standard deviation. The standard deviation is widely used in statistics to measure the spread. It's based on all values in the data. So it is sensitive to the presence of outliers in the data. So calculating the standard deviation is related to the variance of the data. So the variance, when I'm talking about the variance, is just the standard deviation squared. It means the same thing. Standard deviation is the average deviation of all data from the mean. The variance is standard deviation squared. Okay? So the variance is given by this. So look at this formula. It mustn't scare you. We're going to break this down. What does this mean, the variance? X with the I like that implies all the raw data X. Does that make sense? All the X values. And this is the mean. What it means, if I have your marks in the class, that X is each and everyone in that class, and this is the average, then I'm going to minus your marks from the average, your marks from the average, everyone's marks from the average, and square that, and add everything and divide by how many in the class. That gives me the variance. Let's see how we can do this. So the standard deviation is given by the square root of the variance. Because what is the variance? Standard deviation squared. The variance, the standard deviation squared. What is the standard deviation? The square root of the variance. They mean exactly the same thing. They explain the same thing. They explain each and every data set, the deviation from the mean. Okay. Let's look at this data. The midday temperatures in degrees Celsius recorded for 1 week in June. 21 degrees Celsius, 23, 24, 19, 19, 20, and 21. This is the actual data. So the XI is the actual data, each and every data in the set. Are we together? Now, we are going to calculate the deviation, how far. When I say deviation, the distance between 21 and the mean, the average. What is the distance from 21 to the average? What is the distance from 23 to the average? 24 to the average, each and every data set. Hence, we have that XI for it takes each and every data set we have. And what are you going to do? We're going to square that. Because what is interesting, if you just add all this, you're getting 0. Interesting question. The deviation of each, let's say we take in your class all your math marks. We calculate the average. We say whatever you got minus the average, whatever you got minus the average, each and every one in the class, we add all those, we get 0. Think about this. What does it mean? Hence, we're squaring that. Okay, so let's see what we get. Now we want to calculate the mean. So we find the mean. The mean is the X bar. The mean, X with a bar, we call it X bar. It just means the mean, the average. That's another way to say the mean. How do we calculate the mean? We take all the number divided by how many numbers are there. So the mean is 21. Are we together? Then we look at that 21. How far are you from the average? How far is 21 from the average? The distance between that 21 degrees Celsius from the average. That will give us what? 0. Let's go back there. You can see that will give us 0. If we minus the 2, will give us 0. So the distance between that and the average give us 0, because the average is 21. 21 minus the average is 0. 23 minus the average give us 2. 24 minus the average give us what? 3. 19 minus the average give us negative 2. What do those negatives and positive mean? Why are we getting negative? Why are we getting positive there? This is positive, this is positive, this is negative. I want you to think about that now. 19 minus the average, we're getting negative 2. What does it mean? This is negative 20 minus the average. We're getting negative 1. 21 minus the average, 0. We have 0 there and 0 there. Interesting. What I did, I took data. After taking the data, I calculate the mean, which is the average or the X bar. Then I say the actual data minus the average. This is what I get. Why do I get 0 and some positive and negative? Any idea? Think about that. What do you think? Why are we getting positives and why are we getting negatives? It's a simple answer. So what does it mean? 19. Let's start with negative 1. 21 is the same as average. What is the deviation between 21 and 21? 0. The 21 degrees Celsius in the average was the same as the mean. So there's no deviation. Then what about 23 and the average is 2 units above the average? Can you see that? That 23 is 2 units above the average. 24 is 3 units above the average. And 19 is 2 units below the average. It's below the average. And 21 units below the average. And if you look at 21, it's the same as average. As the data set implies 21, I'm getting the same as the average. And what is my distance between the 21 and the average? 0. Now, what we have to do now is to square the deviation. Is to square the deviation. What is the deviation? Those x minus the average. So if you square, what is 0 squared? 0. 2 squared? 4. 3 squared? 9. Minus 2 squared. Very important how we squared. It must be in bracket. Hence we're getting 4. That we get 4 minus 1 squared. We get 1. 0 squared. We get 0. Then we add all this. So we get 22. Now, what does this mean? This is our variance. That will be 22 divided by the size of our data. Are we together? So 22 divided by the size of our data, which will give us 3.143. That's the standard deviation. The average deviation from the mean. That's our standard deviation. Okay, fantastic. So the standard deviation is that. So this is the variance, not the standard deviation. We have calculated the variance. To calculate the standard deviation, we have to take the variance and square the variance to get a standard deviation. So 3.143 is the variance. We square that to get the standard deviation. If we square that, we get 1.77 degrees Celsius. What does that mean to us? That the average deviation of each and every set of data is 1.77 degrees Celsius. Hope this makes sense. Standard deviation. So what we looked at, guys, this is our summary. We looked at measure of central tendency, quartiles, 5-number summary, box and whisker plot, measure of dispersion, range, interquartile range, semi-interquartile range, and standard deviation, which is a powerful measure of dispersion. I think the standard deviation wins. If I look at range, the interquartile range, the semi-interquartile range, there, because the standard deviation uses each and every set of data. But because we use each and every set of data, it doesn't mean it's good. What if you have extreme? Do extreme don't affect standard deviation? Because we know that the semi-interquartile range and the interquartile range, those two measures of spread are not affected by the extreme values. Okay, guys, this is the end of our lesson. I'll say, keep working hard, keep pushing, never give up. Mathematics, it's about consistency. Try, seek help. You practice, and it's normal to struggle. That's the nature of the subject. It's okay. It's okay if you solve a problem you can't do it. But it's not okay not to try again. We have to try, and we have to persist. And I'll say bye, and we hope to see you soon. Cheers.